Hi again, we are on video 3 and we actually have 3 more questions. So hopefully we get finished with the 3 on this video. Alright, so on this one we're finding the weight in ounces of the steel pen shown in the figure if its density is 0.0173 pounds per cubic centimeter. And we're going to round to the nearest hundredth. So first we need the volume of this in order to then calculate the weight. So to find the volume, we're going to use, volume equals the area of the base times the height. And this pen is in a hexagonal shape, so we're going to, it's a hexagonal prism. So we have to find the area of the base, and then the height of it is going to be 6.5. This is A in our formula for a hexagon. So 2.598 times A squared, which is 0.9. And then we're going to take that times our height of 6.5. And with this, then we will be able to calculate the volume. All right. So the volume will be, let me calculate this part, 2.10438. And then we're going to take that. So that was the area of the base, this number. And then we're going to take that times the 6.5. 13.67847, and that is centimeters squared, centimeters cubed. And then I wrote out quite a few decimals here because I don't want to round it too much, and that way when we do our conversion we'll have more accuracy there. And so the conversion is going to be to ounces. So we have this actually is going to be part of our conversion because it tells us that 1 centimeter cubed is 0.0173 pounds. So we start out with our volume, which is in cubic centimeters. And then we're going to multiply that by our weight per cubic centimeter. So I know to put this in the denominator because that is what I want to cancel. And when you set up your conversions this way, then it makes it easy to know what actually cancels and what we end up with in our calculation as our unit. And then last, we're going to convert to ounces. So 16 ounces in 1 pound. And once again, I have to put that diagonal from the pounds because we're going to convert to ounces. All right, so that means that I can cancel my pounds, I can cancel cubic centimeters, and then basically I just multiply and that gives me the number of ounces. So when I multiply straight across, because in fractions we multiply straight across, I get 3.786, and then we're going to round that and label it with ounces. So that's going to be 3.79 ounces, and it told us to round to the nearest hundredth. So that's 2 places after the decimal. All right, so it's a pretty good process sometimes to get all the way to the answer that you're looking for. All right, let's look at this next one. So this one is a swimming pool. It says, how many gallons of water are needed to fill a swimming pool that approximates the shape in the figure? Round to the nearest gallon. So if you just picture this as a swimming pool, the 3 feet would be the shallow end and 9 feet would be the deep end. But the sides of this thing are trapezoids. So that means that our base is a trapezoid. We have 2 of those on either side of this thing. So I'm going to kind of try to make that stand out a little bit. This is our trapezoid, because we need to have our dimensions in order to set up our formula here. Oops, come on. So that's our trapezoid. And so in our trapezoid, we have this height. This is the height of the trapezoid, right? This trapezoid is our base. And then we also have 9 inches and 3 inches, and that's going to be B1 and base 1 and base 2, all right? And this one's B2. Well, I can't quite squeeze that in. I'm going to put it on the other side. And I got an extra thing there. Okay, so the area of the base, because we are finding volume, right? The volume is the area of the base times the height. And so let's just find the area of the base first, because of the formula, right? For a trapezoid is going to be base 1 plus base 2, and then divide that by 2, and then multiply by the height. Now this is a really big swimming pool. As you can see, it's 75 feet long. So that's not your common swimming pool that you might have behind your house. And then when we find our area, it is 450 square feet, or feet squared. And now we can calculate the volume. So the volume of this is going to be 450 square feet times the height of the prism. So this 28 is the height of the prism. Let me write that. That's the height of the prism. So you can't, sometimes it gets confusing because you've got a height of the trapezoid, you also have the height of the prism. Remember, the height of the prism is going to be between the two bases that are the trapezoid in this case, whatever shape it happens to be, that has to be between those. All right, so we're going to multiply this times 28. So the volume is 12,600 cubic feet. And then we just convert that to gallons. Now, I didn't put this conversion on here, but it is on your conversion chart if you still have one of those. Let me write that out. There is 7.48 gallons, or there are 7.48 gallons in 1 cubic foot. And I know that you probably even might recognize that because we've used this a number of times in the past. 1 cubic foot. So this way we get this thing converted to gallons. Once again, we multiply, and it's a pretty large number. It is 94,248 gallons. All right, so we've got that one. And one more. The concrete footings for piers for a raised foundation are cubes measuring 18 inches by 18 inches by 18 inches. How many cubic yards of concrete are needed for 28 footings? So cubes have length, width, height that are all the same. But this is saying how many cubic yards of concrete. So that means that we should do our calculations with yards instead of with inches for sure, because that's going to make this easier to work with. So 18 inches into yards, right? There's 36 inches in a yard. Right, so we're just dividing 18 by 36. So that's going to be 0.5 yards on each side of our cubes, right? So length, width, height of the cube. And actually we can find the volume of a cube using a side to the third power. Now think about that. Whenever we're working with the area of the base times the height, well, the area of our base would be 0.5 times 0.5, and then our height is also 0.5. And so all three numbers that we're using are going to be the same. So our volume is going to be 0.5 to the third power, or 0.125 cubic yards. Now, it tells us that there are 28. How many cubic yards of concrete are needed for 28 footings? And so that means that each one of these cubes is going to be a footing, which we're going to multiply by 28. So that's going to be 0.125 times 28, because there are 28 of them. And so we get 3.5 cubic yards of concrete. And so that is the end of the lesson and the end of this video. Bye, everyone.